Hi my dear students, welcome to one more amazing session from Infinity Learn NEET YouTube channel. This is Suresh, Faculty of Chemistry. Hi Betu, Radhe Radhe, how are you? Fantastic to see you all again. And today I just want to give you the periodic trends. When you start preparing for your periodic table and classification, you study the periodic trend. The moment you see the periodic trend, you will be having a lot of confusions because periodic trends is a collection of a lot of exceptions. And in today's session, आज का सेशन में हम चर्चा करने वाले हैं क्या क्या exceptions है and moreover NEET examination loves exceptions है ना Anuj okay I think that is Sonali Gope hi hello how are you so बच्चों I want to say आज का सेशन में जो जो एक्सेप्शंस है चर्चा करने वाले हैं जो एक्सेप्शन का रीजन भी आपको देना है सो एक थम्स अप एंड फायर इमोजी बिफोर वी स्टार्ट द क्लास पीरियोडिक ट्रेंड्स एंड एक्सेप्शंस यू लाइक दिस स्लाइड मी फाइन बेतु थैंक यू KS Jeril fine so those who are online right now please like the session and share with your friends and subscribe to Infinity Learn NEET YouTube channel. Now, I want to just bring you one important aspect. You are all in the race of the NEET examination to reach your dream medical college. So, for that, you're doing a lot of hard work. Some students are doing 8 hours in a day, some students are doing 12 hours in a day. Doesn't matter, that's all depends on you, how hard you can work. But I have a small excuse in that. Yeah, very good, live facts. Whenever you are preparing for something, you need to know where exactly you stand and what you are doing, what is your improvement areas. अभी मध्य प्रदेश से अभी इतना प्यार से आ रहा है हर दिन क्लास को सोनाली well God bless you. Okay, now get ready and for that if you want to check exactly where you stand you need a proper assessment platform. So this is the NEET test series. Infinity Learn is offering NEET test series. And this test series is designed separately for grade 11 students and 12 and droppers ko bhi. And this is prepared by eminent faculties from the Infinity Learn team and it is based on NEET NTA latest pattern and also it gives you a real-time simulation in the test taking experience. Bacho, it is very important. You can just follow the link that is there in the description box in the live video and you can just click it and go through that and before you just purchase it you can apply YouTube 30 off. YouTube 30 off automatically you are going to get 30% discount. So that gives you a lot of support when you go ahead with your NEET examination preparation bacho. I don't want to take much time to reveal the things. Let us directly dive into the periodic properties बच्चों in this periodic properties you have चाहे इसको atomic radius होगा ionization energy electron affinity and electronegativity सारे चीज़ हम discuss करने वाले total. So what is atomic radius? The distance between the nucleus and the outer electron, that is called atomic radius. Is it possible to exactly measure this value? This is the nucleus and this is the outer electron. So actually electron is a cloud, it don't have a proper boundary. So to find that we have various types of radius scenario, that is going to be atomic radius given in the form of metallic radius, van der Waals radius and the covalent radius, depends upon the type of bonding between the atoms. Actually atoms are not found in the free state. So let's talk about the trends in the atomic radii. You can say covalent radii, you can say ionic radii. I don't want to discuss about the definition and explanation of these periodic properties. Rather, I want to give you the trend in the periodic properties, bacho. And define here various trends. You can say half of the internuclear distances. Chlorine, fluorine, chlorine, bromine, iodine. As the atomic size increases, radius also increases. Betu, here you can see the trends over here, हाँ या मुझसे वेट देखकर मोल सीखना है। अगली क्लास में मोल्स का कैलकुलेशन आपको दिखाना चाहता हूँ सोनाली। सो वेरियस पीरियोडिक ट्रेंड्स, इफ यू सी दिस down the group, atomic size increases. You can see any group atomic size is increased. Do we have to memorize all these values? Of course no. There are some exceptions. I just want to show you. Down the group, atomic size increases. Across the period, atomic size decreases. There are a bit of controversies. Do we have to take what kind of radius in the case of group 18 elements? Group 18 elements, only van der Waals radius is considered, and the van der Waals radius values are 40% bigger values. So rest of them you can take covalent radius, metallic radius, ionic radius, whatever it may be. Let us see glitches. Let us see the exceptions here. When you see the atomic number and atomic radius, so the radius is going to be increased and decreased, increased and decreased, increased and decreased, you can see. By looking at this graph, what I can say here? Alkali metals are the largest atoms in the periodic table. Z effective increases, atomic size decreases. If you go into the Z effective atomic attractions, nuclear attractions, again you have to say screening constants, lattice rules. Once you start learning lattice rules, you will become dumb. So I don't want to take you in that way. So the lowest value, if you take here, noble gases, as across the period the size decreases. If you ignore the van der Waals radius, 40% कम करके देना. And you can see the transition elements, the atomic size is close, very, very, very close. Yes, this is the pattern you can understand. And where is some exceptions? Let us see here. All periodic properties I just want to show you. Understand the pattern, don't by heart the pattern. बच्चों अगर कुछ डाउट है ना तो आप पूछना है. Okay, so now you can see here, when you talk about ionization energy, again ionization energy is the amount of energy that required to remove the electron from the outermost electron of an isolated gaseous neutral atom. Smaller size will have greater ionization energy. Bigger size atom will have lower value of ionization energy. You know, effective nuclear charge increases, ionization energy increases. Betu, yes, exactly. Now that's the reason why the biggest atoms are alkali metals, na? Lithium, sodium, potassium, rubidium, cesium will have the lowest values of ionization energy. Noble gases are the elements having the highest ionization energy. You know, helium is the element with highest ionization energy. And you can see the cesium is the element with the lowest ionization energy. So when this graph is printed somewhere in the textbook, or if this graph is not there in the textbook, examination is, the graph is given and simply it is given there is an element X. So the X could be option A, B, C, D. You have to spot out. Based on this graph, it is the highest, isn't it? Now आज का सेशन में हमारा मेन कोर्स ये नहीं है, एक्सेप्शन कैसे निकालना है. First let us see the general trends, then we'll see in the exceptions. So everybody who are online, please take a pen and paper, write all the exceptions that I am going to give you, including oxides and hydrates as well. And bachcho, don't feel the session is running like a train. So first ionization energy values are presented to you to make you to understand, not to by heart. Please don't by heart anything. Now helium is the element having 2370 kilojoule per mole, highest value in the periodic table. And cesium is the element with the lowest value in the periodic table, not francium, because francium का बारे में scientist को भी नहीं पता है, because it is a radioactive element. It is not giving that chance to measure this ionization energy. And you can see these values are zigzag. Transition series का value zigzag दिख रहे हैं. And if a question is asked, you can't classify this question is based on D and F block element, S block and P block and periodic table and chemical bonding. These are all integrated, bachcho. That is the reason why I just want to give you the highest ionization energy. You can see some abnormality with the nitrogen as well. So it has to increase. Yes, it's increasing, and there oxygen, nitrogen is greater than oxygen, nitrogen is greater than carbon as well, due to half-filled electronic configuration. Half-filled electronic configuration, fully filled electronic configuration are stable. ऐसे इलेक्ट्रॉनिक कॉन्फ़िगरेशन से इलेक्ट्रॉन बाहर निकलना बहुत मुश्किल काम है. इसके वजह से इस जैसे एलिमेंट्स है ना, they have highest, relatively highest ionization energy. So we'll see that. बच्चों, you can see electron affinity. So that completely the opposite process of ionization energy is electron affinity. The amount of energy released when an extra electron is added to isolated gaseous neutral atom is electron affinity. It is an exothermic process. That is the reason why all values you can see in the negative values. And you see some values are going to be positive values because noble gas completely filled shell is there. And also, if you want to add one more electron, you have to add to the next energy level. As a result of this, it will have the positive value. So moving ahead, what are the exceptions here? So variation of the covalent radius of the group 1 elements, bachcho. These graphs are very important. You can see lithium, sodium, potassium, rubidium, cesium. Now there is a glitch. There should be increase in the value of these, but there is a sudden increase from the sodium to potassium because d orbitals. Because of the d orbitals, the volume of the potassium is suddenly increased. Assertion reasoning questions are important for NEET examinations, right? So this is way you have to, you are preparing. When you prepare, you have to spot out that kind of abnormalities. And moving ahead, if you have any doubts, and meanwhile you can ask. Those who are in online, please like the session. This is a live interactive session. You please ask doubts. So I will be delighted to answer any kind of doubts. Now, variation of ionization energy in the first period. As I say here, ionization energy increases from lithium, sodium, potassium. So in the first period, first period, lithium, beryllium, boron, carbon, nitrogen, oxygen, it goes like this. Why there is a down? There is a down P1 configuration. So this is a lithium, beryllium, and this is a boron. Boron, always first ionization energy of this group 13 is less as compared to the group 2. And moving ahead, variation of ionization energy in the group 1. As I mentioned, down the group, ionization energy decreases. Lithium, sodium, potassium, rubidium, cesium. You know, atomic size of the potassium suddenly increased. Therefore, ionization energy suddenly decreased because of presence of vacant d orbital. Always in the periodic table, you just see period 3 will be having abnormal properties due to the presence of the vacant d orbitals. That is the general thumb rule that you have to use in the any trend. चाहे आपको S block हो सकता है, P block हो सकता है. So a strongest chain can break at the weakest link. Yes, chemistry is going to be a super awesome scoring. Sonali Gope, right? Bachcho, you can see here one more important parameter. So take a pen and paper, write these graphs and abnormalities. Variation of electron affinity along the group 1 period. Period 1, you can see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Oxygen is the element. Okay, this is the fluorine beta. This is the fluorine. Fluorine is the element with highest electron affinity in the period 1. Such questions will be there. Yeah, my education, thank you very much. And you can see this nitrogen will be having the lowest as compared to the carbon and oxygen due to stability of P3 configuration, and highest will be the fluorine. Second highest is going to be the oxygen beta. So NEET examination is going to be micro and granular level. Fact is fact. Wherever Mayank, it is a live beta. Don't you feel it is live? In your chat, I am going to respond directly, so it's a live session. Mayank, yes, it is a live session beta. Moving ahead, and variation of electron affinity in first period. Hello Mayank, come on. So it is going to be fluorine and chlorine and bromine and iodine and astatine. Now we know that electron affinity value is decreasing down the group, but there is a sudden increase in the chlorine value. So chlorine is always greater than fluorine. Due to small size of the fluorine, inter-electronic repulsions will be there. To overcome the inter-electronic repulsions, we have to push some energy inside the system, so that the released energy is totally, when it comes to the thermodynamic accountability, fluorine electron affinity magnitude is less than chlorine electron affinity magnitude. That is the appropriate reasoning for the question. Dear children, a NEET examination is focusing nowadays. You just analyze the last 5 years questions. The question paper is not testing you the lengthy numericals in the chemistry and how depth out of the textbook you know the subject. Rather, the question paper is prepared in such a way that only basic level questions will be asked, and a reasoning and subject applications are tested in the NEET examination. So I strongly advise all the students preparing for NEET 2026, you focus on the things fundamental level and analytical things, and this is the crystal clear example. You need to know the reason for that. Every exception you need to know the reason. Okay, so Zeldal method is important for, yes, it is important for any kind of examination. So variation of electronegativity in the period, yes, fluorine is the high 4.0 and it is the most electronegative element, and the next oxygen and nitrogen. So it is going to be increased across the period, no abnormalities are seen. And moving ahead, talking about the Pauling scale electronegativity, you can see the highest electronegativity atom is the fluorine 4.0. Lowest electronegativity is going to be cesium 0.7. Metallic nature is directly proportional to electronegativity. Non-metallic nature is inversely proportional to electronegativity. So that metallic nature increases across the period and non-metallic nature increases across the period, and metallic nature increases down the group. So you all understood this? Can I skip purification? No. It is a practical chemistry. Definitely you will be having a question in any examination, bacho. It's very important, very important. And moving ahead, bacho, and variation of electronegativity in group 1, it is decreasing. You know, lithium, sodium, potassium and rubidium and cesium. The electronegativity value of potassium and rubidium is same, you can see. Potassium and rubidium is same. Similar electronegativity values are seen. Carbon 2.5, hydrogen 2.1, and this similarity makes the electronegativity scenario an inductive effect. So carbon to hydrogen bond is taken as a standard for inductive effect. So these are the applications of the electronegativity bacho. And also you can see important orders in inorganic chemistry. Yes, can I skip idli for a whole 2 months for JEE mains? No, I am not going to entertain any comment or any question out of the academics. Okay, Sonali, okay, I like your questions out of the inside the context, and please avoid out of the context to maintain the chart diagram. Bacho, all the best, Mayank, and all. Not only I am coming out of the periodic table, I connect with hydrogen. S block, P block, D and F block, and overall inorganic chemistry orders I just want to show you here. So hydrogen has एक बार और Simpa do please. Which one? Which one? Okay, look at this. Look at this. Mayank is requested. Any request from the chat box is definitely honored, bacho. Okay. So I want to say here Pauling scale electronegativity values. Here electronegativity is a measure of the metallic and non-metallic nature. So as electronegativity value increases, non-metallic nature increases, and electronegativity value decreases, metallic nature increases. So down the group you can see the values are decreased, metallic nature increased. Okay, and across the period you can say electronegativity value increased and metallic nature decreases, non-metallic nature increases. And highest is going to be 4.0 is the attributed to fluorine. Abhi slide hai na. Now you can see the similar values potassium and rubidium 0.8 ka hai. Wherever you have a similar values, that may be a question in the NEET examination. Okay, Ruhi. Now you can see the similarity in nitrogen and similarity in chlorine you can see. So there are two elements, nitrogen and chlorine, similar electronegativity values. There are two more elements, potassium and rubidium, similar electronegativity values. Right? Rohi, hope you understood. Yes. And actually, the carbon is having 2.5 and hydrogen is having 2.1. These values look similar. So as these values are similar, इंडक्टिव इफेक्ट ऑर्डर निकालने के लिए कार्बन टू हाइड्रोजन इलेक्ट्रोनेगेटिविटी डिफरेंस इज टेकन एज अ स्टैंडर्ड सो दैट ए डिफरेंस के हिसाब से पॉजिटिव इंडक्टिव इफेक्ट नेगेटिव इंडक्टिव इफेक्ट इज टोटली डिफाइंड ओवर देयर. बेतु फाइन, वेरी गुड. नाउ वी कैन से हियर आल्सो cobalt, nickel, copper electronegativity values are same. You need not have to worry to go so intrinsically, just see only well known elements. Any doubts, bacho? You like this? Take a screenshot, everybody. Everybody take a screenshot so that we'll talk about. Moving ahead, various exceptions based on this important orders in the total inorganic chemistry. Now you can take a pen and paper. We have hydrogen, deuterium and tritium. These are the three isotopes as far as the hydrogen is concerned. Aap Madhya Pradesh se hai na? And you can see relative abundance, atomic mass, melting point, boiling point, enthalpy of fusion, enthalpy of evaporation, bond dissociation energy. This is very, very important. This is very, very important. Bond dissociation energy, that is given as deuterium is greater than hydrogen. And Mayank, definitely I will explain here. So the entire thing you need not have to know, you have to know this. That is the reason why D2O is less reactive as compared to H2O. H2O is a normal water, D2O is a heavy water. Mayank, I'll come back to you, don't worry. And based on this, deuteration happens in the organic chemistry, tautomerization as well. And this can give you impact. The bond energy of the deuterium is greater than bond energy of the hydrogen. And moving ahead a little bit, group 1, group 2, group 13, 14, 15 and everything I want to give you here. So ionization enthalpy of lithium, sodium, potassium, rubidium, cesium, it's normal. Down the group, ionization energy decreases. And also you can say hydration energy. Hydration energy is also lithium greater than sodium, potassium, rubidium, cesium. Hydration energy decreases. Metallic radius increases. Lithium less than sodium less than potassium, rubidium, cesium is the greater. And melting point is also the same way as compared to the boiling point. And I want to say here one more important, density of lithium, potassium, sodium and rubidium and cesium. I just highlighted here. There you are going to, so boiling point is the temperature at which a liquid is converted into its vapor. Mayank, that is called boiling point. So which of the following is true? Orders will be A, B, C, D options. So you need to know, because here you can say potassium less than sodium, that is the density. So very important, because of, I explained you, because of this sudden increase in the volume of the potassium, its density is decreased. You understand, Mayank? And also standard reduction potential. So potassium is less and highest is going to be lithium. So in the entire electrochemical series, this is the highest. And a strong reducing nature. Occurrence on the lithosphere is not that required. Okay, so this is important, my dear students, and this is also important. And in the NEET examination, wherever exceptions are there, NEET always loves exception. Fundamentally, you need to know. Yes, and moving ahead, group 2, you are going to have ionization energy. So beryllium, magnesium, calcium, strontium, and radium is less than barium. Okay, so barium is less than radium, that is the IE2 is greater than IE1 for this. As this is radium and barium scenario, it is completely down the group, we don't want to talk about this. And hydration energy, metallic radiation, everything is same, not abnormal. And you can see melting point, magnesium is having the lowest melting point in this group 2 elements. Thank you, Mayank, thank you very much, thank you, right? And also boiling point for the magnesium is also very less. Why? Because intermolecular or interatomic forces are very weak in the case of magnesium. Talking about the density, so beryllium is the element, it is supposed to be the least, but the calcium is the element, is the lightest in the group 13. Heavy water is used in NMR spectrometry. Okay, that's a big science. So right now you don't need it, otherwise I would have given that. Okay. So which of the following element is the least dense in the alkali earth metal? Calcium. And a standard reduction potential is same, and occurrence in lithosphere, you don't need it. Moving ahead, and atomic radius, group 13. So boron, aluminum, gallium, indium, thallium, but aluminum is greater than gallium because of d orbital contraction. Ionic radius, you don't have the abnormality. Group 13 is very important. Definitely I am going to expect a question at this place. Beto, why is the density of heavy water is higher than that of normal water? Because density is equal to weight by volume. Heavy water has more molecular mass, so density is more. Beto, fine? Okay, yes sir, no charting, please maintain the chart decorum, bachcho. And ionization energy, sum of the ionization energies. So group 13 elements has Ns2, Np1, 3 electrons are there in the outer shell. So they will be having IE1, IE2, IE3. If required, you need to know only the order of the IE1. Your IE1 of aluminum, gallium, thallium, boron. Boron is the highest ionization energy. And you have the abnormality due to involvement of the d orbitals in it. It gives you a lot of importance in various aspects. Bachcho, this table has been prepared based on the NCERT database that is given. Everybody focus there. If you have any doubts, you can ask us. Okay, Mayank, Beto, right. Now moving ahead, group 13 electronegativity. the most electronegativity atom in the boron and the least electronegative atom is going to be aluminum. So there is a sudden decrease in the electronegativity of the boron to aluminum. So it is going to be down, and the values of gallium, indium, thallium are going to be nearly same. So first two elements in the entire periodic table, so you see the p block, okay, atomic number and electronegativity, you see it is going to be the first to second element, and there will be almost similarity and slight decrease in the electronegativity. That is the trend you can see in the total p block element, and this information graphically you can see. If this pattern is seen in the any one of the options, you can say it's a p block element. And density and melting point, gallium has a lowest melting point because it exists as a Ga2 dimeric structure. Ga2 dimeric structure. What is electronegativity? The relative tendency of an atom to attract shared pair of electron more towards itself is called as electronegativity, and this is a relative phenomena. So that to measure the electronegativity, we don't have any units, rather you have a scale. You can use Mulliken scale or you can use Pauling scale. So that is about the electronegativity. Anuj, Gope, Gamer, so Sonali, Gope, fine. What is atomic radius, Mayank? Atomic radius is the distance between the electron and the nucleus. Fine. It is important, it is difficult to measure the atomic radius, so that you have a covalent radius, a metallic radius, van der Waals radius, and ionic radius, right? Moving ahead, group 14 elements, atomic radius normal and ionic radius normal. So ionic radius, I don't want to give you the carbon because carbon do not form free ions. And you can see ionization energy is normal, it is coming down. But there is an abnormality here, my dear children, there is an abnormality here. Tin lead, that is the abnormality because of the involvement of the f orbitals, poor screening effect of the f orbitals. Okay, so these are the various orders of the group 14. And also let's talk about electronegativity. Carbon is greater than silicon, germanium, tin, already I said. What is the valency of carbon? No, beta, what is this? Valency of carbon is 4, na? Let us not use simple questions, rather your question should create an impact in the entire class. So students are watching this live, preparing for NEET examination with lot of efforts, so that impact should raise the competitive spirit. Okay, Sonali, so density and melting point and boiling point, everything, and you can see group 15. Group 15 p block elements in the grade 12 NCERT textbook, it is going to be very important here, bacho. So atomic radius, ionic radius, ionization energies. Nitrogen is having the highest ionization energy, so it's almost like a noble gas because of this p3 stable electronic configuration, bacho. And electronegativity, you see, nitrogen, phosphorus, arsenic, it is going to be almost similar from here to here. I already mentioned the p block elements, sudden decrease in the atomic electronegativity, then it maintains consistency. Okay, right? So melting point, boiling point, density. Now group 16, electronegativity, electron affinity is very important here. So ionization and so electronegativity, oxygen, sulfur, selenium, tellurium, polonium. Now melting point and boiling point, electron gain enthalpy is very important. We expect oxygen is having the highest electron gain enthalpy, but it is the least due to the small size, right? And moving ahead, group 17, 16 element का hydrates जो आता है ना, that is very important. Hydrates of group 15, group 16, group 17 plays a crucial role, and oxides also. Based on this, definitely you are going to get a question from NEET examination 2026. Get ready. Here, melting point H2S, H2SE, H2TE, H2O. Why H2O is highest? Somebody tell me why. Due to whenever intermolecular hydrogen bonding is there, you are going to have highest melting point. Anush, right. Boiling point, melting point is the same order here, and you can see, right, group 17 atomic radius, ionic radius, ionization energy, everything is same. Electron gain enthalpy, you see, we are expecting chlorine is less than fluorine, but here chlorine is greater than fluorine due to its small size of the fluorine. Inter-electron repulsion takes place. To overcome this inter-electron repulsions, the fluorine has to be given excess amount of energy. Therefore, the magnitude of the energy released by the fluorine is less as compared to the magnitude of the electron energy released by the chlorine. That's the reason why this is a super important point. Definitely you are going to get a question based on this. And electronegativity is the same: fluorine, chlorine, bromine, iodine, enthalpy of hydration, melting point, and the boiling point. So you see the melting point, iodine is highest. It is a solid. Bromine is a liquid. It is a solid. It is a liquid, it is a gas, and it is going to be a gas. Intermolecular force is directly proportional to the size of the atom. And moving ahead, densities, bond length, bond dissociation energy. This is important. This is important. Yes, bond dissociation energy of fluorine supposed to be high, but it is less. Because it is due to small size, the lone pair of the fluorine, bonded fluorine atoms come close. Because of this closeness of the lone pair, they start making repulsion so that the fluorine atoms can be easily separated. And this is a reasoning questions also, it's very important. Due to lone pair repulsions, lone pair and lone pair repulsions. And read the statement properly. Lone pair of the total bonded atoms. And talking about the hydrates of group 17, HF you have intermolecular hydrogen bonding, hydrogen and fluorine and hydrogen and fluorine. You will be having a partial negative charge and a partial positive charge. Due to intermolecular hydrogen bonding, HF has boiling point is highest. HF has boiling point highest. Every point to be noted along with the reasoning. Bacho. And also group 18, it is as usual, it is helium greater than neon, argon, krypton, xenon, radon. You don't have that specific things as far as the group 18 is concerned. Wherever you have the abnormality, group 13, 14, 15, 16, 17 तक होगा. 18 में इतना काफ़ी चीज़ नहीं है. So, बच्चों, those who are online, please like the session. Now, direct exceptions. Synopsis of the exceptions. Let us see atomic radius. Only 1 or 2 points. बकवास नहीं देचा. So, you don't have lot of junk as well. If you talk about exceptional order, boron, aluminum, gallium, indium. So why this is expected one is this, but it is not correct. Actual order is a boron, gallium, aluminum, indium, thallium. This is actually the correct, and this is expected, which is wrong. So assertion reasoning type questions. Simple reason is going to be gallium has a smaller size because of the poor shielding effect of the d orbital bus. Like this, Betu. So from now onwards, next 10 slides I want to give you that. Everybody, take a pen and paper, write down expected order as well as actual order behave. Moving ahead, ionization energy. we are going to expect boron is greater than aluminum, but here we see aluminum is less, boron, thallium, gallium, aluminum, indium, NCRT value का हिसाब से. The reason is, on moving down the group, ionization energy decreases. This is true for boron and aluminum, latter zigzag due to d orbital involvement. And also Lewis acid strength. So what is the meaning of Lewis acid? Tendency to accept electron pair. Expected BF3 should be greater BCl3, BBr3, Bi3. But it is completely reversed. It is going to be like this. Why? Because boron, you see fluorine and fluorine sp2 hybridized, and there is an unhybridized pure p orbital lies perpendicular to the boron, and this is going to be the fluorine, this is going to be fluorine, has a lone pair of electron, and this is given back. This is what is called as a back bonding, making the vacant orbital of the boron is less available. This is what is called as a back bonding. This is what is called as a back bonding. And also acidic strength. You see acidic strength expected H3PO4, H3PO3, H3PO2. You know acidic strength is directly proportional to electronegativity, is directly proportional to oxidation state. You can see +5 oxidation state, +3 oxidation state, +5 oxidation state. This is my expectation. But here it is completely different. Reverse, actual order is this. Actual order is this. And this is an exception, and in that this can be explained on the basis of stability of conjugate base. Once it is more stable, the conjugate base, more is going to be the acidity. So the stability of this conjugate base is attributed to the resonance. So the actual order is going to be this much. Any doubt? Those who are online, please like the session, share with your friends. And moving ahead, bachcho, electron affinity. Electron affinity also plays a great role. Expected fluorine is greater than chlorine, is greater than bromine, is greater than iodine, but the actual order is going to be chlorine is greater than fluorine. The reason is due to interelectronic repulsions. 3 times we discussed in today's class about this, bachcho. And moving ahead here, similarly the same sequence is seen in the group 16. Sulfur is greater than selenium and oxygen को कम से कम होना है polonium के बाद. And these are all the exceptions, right? And also you see bond dissociation energy, fluorine greater than chlorine. It is expected but is not correct. But if fluorine comes between bromine to iodine, because due to lone pair repulsion, the reason is given due to inter-electronic repulsion between fluorine to fluorine. This is the lone pairs, and they दोनों का बीच में repulsions होना चाहिए, right? Assertion reasoning type questions are very important for any competitive examination that you are writing. Okay, Anuj and Betu and all students, Mayank, are you there? And जोश बढ़ने के लिए क्या करना है? thumbs up and fire emoji in the live session, बच्चों. And also so many things are there, बच्चों. Boiling point. HF is expected to less than HCl. Boiling point is directly proportional to molecular forces. Boiling point is directly proportional to the molecular weight. But the thing is, due to intermolecular hydrogen bonding, you can see this. HF is going to have the highest boiling point. Fine, highest boiling point due to intermolecular hydrogen bonding. Moving ahead, boiling point भी और एक चीज है. So it's an awesome exceptions I just want to discuss. pH3, hydrates of group 15. Hydrates of group 15, definitely you can expect a question from the NEET. So based on hydrogen bonding, but actual is going to be pH3 less than ASH3, NH3, SPH, BiH3. Here I just want to say molecular weight as well as intermolecular hydrogen bonding. Here this answers intermolecular hydrogen bonding and this answers this molecular weight. So antimony, bismuth are heavier elements, so their boiling points are high. But you are misdirected based on the hydrogen bonding. This is not actually true in the case. Moving ahead, the boiling points of group 16 elements. So as molecular weight increases, boiling point is expected to increase. But here only and hydrogen bond works. So hydrogen bonding plays a crucial role here. So due to presence of intermolecular hydrogen bonding, H2O has high boiling point. Bacho, clear? If you have any doubts, please let us know. So I am telling expected order, actual order and reason for that, so that you can have multiple choice question, actual answer निकाल सकते हैं, assertion and reason का वजह से आपका proper explanation भी निकाल सकते हैं. And also moving ahead, in the exception, alkali metal except lithium cannot react with nitrogen gas. No alkali metal can react with nitrogen gas directly, rather lithium can react diagonal relations का वजह से. Ionization energy, expected order across the period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. But the actual is going to be beryllium is greater than boron. Okay, nitrogen is greater than oxygen because nitrogen has a half-filled electronic configuration. Beryllium has a symmetric electronic configuration. So that's very important here. Reason, the same penetration ability, and nitrogen has a half-filled electronic configuration, stability. So what not? So many exceptions are discussed in today's class, bacho. Hope you understand this. And category, order, all these things in general inorganic chemistry we already discussed. And super important thing, stability of the +1 oxidation state. बहुत काफी important है. Stability of +1 oxidation state here. Thallium is more stable due to inert pair effect. What is inert pair effect? The reluctance of an pair of electrons present in the ns orbital to unpair in order to get participated in the bond formation, so that the pair of electrons do not come out. So that effect is called as inert pair effect. So inert pair effect की वजह से thallium +1 oxidation state काफ़ी important होगा, काफ़ी stable होगा. And moving ahead, basic nature of the oxides, relative strength of Lewis acids, we discussed ionization energy, reactivity and the metallic character. And group 13 elements के इतना काफ़ी आपका exceptions भी है. Fine. Any doubt? Now talking about this group 14 का है, group 15 का है, and you can see oxidizing character of +4, again M+4 species का electronic configuration and inert pair effect का वजह से आप लिखना है. And moving ahead, basic nature and the bond angle and thermal stability of group 15 elements and the halides of the group 15 elements, and take a screenshot of this, and if you have any doubts please let us know. And also bachcho, you are going to get various exceptions in the group 16 as well. We already discussed, एक ही slide में आपको देना चाहता हूँ. So Anuj, you kept quiet, Asir and Betu, if you have any doubts please let us know. And group 16 का oxides and halogen का, right? Betu, I think these slides you can take, you can review of this and you can take a screenshot of this and you can do it, right? That's good. Stability of halogens in the water, fluorine, chlorine, bromine, iodine. And as I mentioned, when you are preparing for your NEET examination, it is important to know where exactly you stand. For that you need a proper assessment platform. NEET Infinity Learn, we are offering you a NEET test series. It is an ultimate key to NEET success. And it is based on the latest NTA pattern. PPT is very beautiful, thank you. And it is based on the latest NTA pattern and also created by top level NEET faculty in the Infinity Learn. And you know, it gives a real-time test taking simulation. So you all just click in the description box and you just go through that description box link and you just apply YouTube 30 of coupon code, so that you will be having a special offer of 30% discount, so that you can just go ahead with that. Okay, so I am done from my side. Hope today's session helped you a lot to understand not only the orders, total inorganic chemistry as a glance. You know, please like this session, share with your friends, subscribe to Infinity Learn NEET YouTube channel. Thank you. Signing off, Suresh, Faculty of Chemistry from Infinity Learn. God bless you. We'll meet with more stuff in the next class. Thank you very much. Thank you, Betu. Thank you, Anuj, Mayank, all the students. Bye-bye.